In January 1947, in a federal courtroom in Lower Manhattan, a young man in an army uniform carried a heavy leather bag past the defense table. Inside were 13 folders pulled from a locked file room in Essen, Germany, the private records of the Krupp steel empire. He guarded that bag so closely, he took it with him to the men's room. The documents inside would help convict General Electric, its Detroit subsidiary, the Carbide Company, and two of America's most respected engineers of running a price-fixing cartel with Hitler's favorite arms maker. But to understand how an American tool company ended up on trial beside Krupp, you have to start 50 years earlier, in Paris, with a chemist who was trying to make diamonds. You're watching Trade Archive, the channel that digs into the companies, machines, and materials that built the industrial world. If this is the kind of story you want more of, like this video and subscribe before we go any further. Now, Paris, 1892. Henri Moissan was already famous when he built his electric arc furnace at the Sorbonne. He had isolated fluorine, the most violent element in chemistry, a feat that had injured and killed chemists before him and would eventually earn him the Nobel Prize. But Moissan wanted something bigger. He wanted to manufacture diamonds. His furnace could reach temperatures beyond 3,000 degrees Celsius, hot enough to melt almost anything humanity had ever dug out of the ground, and he fed it everything: iron, sugar charcoal, crucibles of molten metal quenched in water. He believed carbon under heat and pressure would crystallize into diamond, and he spent years chasing it. He never got his diamond. The glittering crystals he pulled from his furnace turned out, decades later, to be silicon carbide, a material now named moissanite in his honor. But somewhere in that obsessive campaign of melting the periodic table, around 1893, Moissan combined tungsten and carbon in the white heat of the arc and produced a dark, dense compound the world had never seen. Tungsten carbide. It was roughly twice as dense as steel. It was stiff almost beyond measurement. Its hardness sat just below diamond itself, harder than sapphire, harder than any tool steel ever forged, and it was completely useless. Because tungsten carbide had one fatal flaw: it was brittle. Strike it, and it shattered like glass. You could not machine with it, drill with it, or cut with it. For 30 years it stayed exactly what it was in Moissan's laboratory, a scientific curiosity in a drawer. Moissan died in 1907 at 54, months after collecting his Nobel Prize, his health wrecked by years of fluorine exposure. He never knew what his accidental compound would become. The material was waiting for a problem worth solving. That problem arrived not in a steel mill or a machine shop, but inside a German lightbulb factory. After the First World War, the Berlin lighting combine Osram, its name stitched together from osmium and wolfram, the German word for tungsten, faced a production bottleneck that was quietly bleeding it dry. To make an incandescent bulb, you pull tungsten through a series of dies until it becomes filament wire finer than a human hair. Tungsten is brutally abrasive. Steel dies wore out in hours. The only thing that survived was diamond, and drawing dies made from industrial diamonds were staggeringly expensive for a company producing millions of bulbs. Osram needed a substitute, and it handed the problem to the head of its research laboratory, an engineer named Karl Schröter. Schröter went back to Moissan's brittle curiosity, but he came at it through powder metallurgy. Attempts to press and sinter pure tungsten carbide into dies had been made as early as 1914, and every one of them failed the same way. The dies cracked. Schröter's insight was that the carbide did not need to be improved. It needed a partner. He mixed fine tungsten carbide powder with a small amount of a softer metal, trying iron, trying nickel, and finally settling on roughly 6 to 10% cobalt. He pressed the mixture into shape and heated it to a temperature just below the melting point of the carbide but high enough to melt the cobalt. The cobalt liquefied, flowed between the carbide grains, wetted every surface, and froze into a tough metallic skeleton that cemented the hard particles together. The result combined the hardness of tungsten carbide with the shock resistance of metal. Cemented carbide. Hard metal. Schröter filed German patent number 420,689 on March 30, 1923, and it stands today as one of the founding documents of modern manufacturing. Osram put the new material into its wire-drawing dies and retired its diamonds. Then it did something that looks almost unbelievable in hindsight. Osram was a lamp company. It had no interest in becoming a tool company. So at the end of 1925, it sold the rights to the most important tooling invention of the 20th century to the steel and munitions conglomerate Friedrich Krupp of Essen. By February 1926, Krupp had stood up a working group with a budget of 70,000 Reichsmarks, and that same year it brought the material to market under a name that told you exactly what it was selling. Widia, short for the German phrase wie Diamant, like diamond. At the Leipzig trade fair, machinists watched Widia-tipped tools tear through steel at speeds that made their high-speed steel cutters look like hand files. Cutting speeds did not improve by 10 or 20%. They multiplied. Across the Atlantic, General Electric was watching. GE was one of the largest consumers of drawing dies and cutting tools on Earth, and it already held American lamp field rights to Osram's patents. In 1925, a GE research engineer named Samuel Hoyt was in Germany on other business when he met Schröter at Osram and came home carrying a sample of the new hard metal, a sliver about 1/4 of an inch square and 5/8 of an inch long. That sliver went into GE's laboratories in Schenectady, and within 3 years, GE was producing cemented carbide for its own dies and machining operations. The man who saw what it truly meant was Zay Jeffries, a metallurgical consultant to GE's National Lamp Works in Cleveland, and one of the most brilliant metals men in America. Jeffries pushed GE's leadership to go all in, not just for light bulbs, but for the entire American cutting tool market. GE had a choice. Krupp held the Schröter patents. GE held its own overlapping patents and processes. They could fight it out in court for a decade, or they could make a deal. In 1928, they made the deal, a tentative agreement on April 17th and a definitive contract on November 5th. Krupp assigned General Electric its present and future American patent rights to hard metal. In exchange, GE agreed to fix prices, to bind any licensee to those prices, and to pay Krupp a royalty on every pound produced in the United States, with a fund collecting $5 per pound from licensees and 2/3 of it flowing to Essen. In September 1928, GE incorporated a subsidiary in Detroit to carry the business and gave the material an American name, Carbaloy. Jeffries served as its technical chief, became its president in 1932, and rose to chairman of the board in 1936. Within a generation, machinists across America would stop saying tungsten carbide at all. They just said Carbaloy, the way you say aspirin or thermos. Through the depths of the Great Depression, while factories around Detroit went dark, Jeffries steered the young company into every corner of American industry that could still afford it. Wire drawing dies for the cable makers, tooling for the automakers who survived, wear parts for gauges and instruments that had to hold a dimension for years. The product line worked. The tools cut faster and lasted longer than anything the trade had ever handled. That was never the problem. Understand what it actually took to make this stuff, because nothing about it resembled ordinary manufacturing. It began with tungsten ore, wolframite and scheelite, crushed and chemically refined into tungsten oxide, then reduced in hydrogen furnaces into metallic tungsten powder. That powder was blended with carbon black and carburized at around 1500 degrees Celsius until it became tungsten carbide powder finer than flour. The carbide went into ball mills lined with carbide, tumbling with carbide balls and cobalt powder in a bath of solvent for days on end until every microscopic grain was coated. Pressed in steel dies, the mixture came out as a compact with the strength of blackboard chalk. You could carve it with a pocket knife. Workers gently machined these chalk-like blanks into shape, then loaded them into sintering furnaces at around 1400 degrees. Inside, the cobalt melted and pulled the whole body together, and the part shrank by nearly a fifth in every dimension, roughly half its volume, so every die had to be cut oversized to precise mathematical allowances. What came out was a dense, gray solid approaching 92 on the Rockwell A scale, so hard that the only way to finish it was grinding with diamond wheels. And because the material cost so much, no one made solid carbide tools. A small carbide tip was brazed into a slot on a steel shank, and even that thumbnail of carbide could be a third to half the cost of the finished tool. Which brings us to the price. Before the agreement between General Electric and Krupp, imported cemented carbide sold in America for around $48 a pound. When Carbaloy took over the market, General Electric set the first price at $453 a pound, $1 per gram, for a material that Carbaloy's own president would later testify cost between 6 and 12 cents a gram to produce. Inside General Electric, at least one engineer knew exactly how absurd this was. A Schenectady employee named W.L. Merrill dropped a note into the company suggestion box, pointing out that making cemented carbide was about as complicated as mixing, in his words, a good grade of concrete for a sidewalk. He calculated the cost at roughly $8 a pound and proposed selling at $50, which he noted would still deliver about a 7-to-1 markup. The suggestion went nowhere. The price stayed in the hundreds of dollars per pound for most of the 1930s. And the cartel defended that price like territory. General Electric told Krupp it intended to keep American licensees to a bare minimum, preferably no more than 2, and that is what it did. Firth Sterling Steel and Ludlam Steel got licenses, legally bound to sell at prices and terms no more favorable than Carbaloy's own. Everyone else got the door. The Crucible Steel Company asked for a license in 1936 and was refused. Chrysler asked in 1938 and was refused. Ford asked and was refused. The independent importers who had built the American hard metal trade before 1928 were dealt with one by one. Morris Simons of the Union Wire Die Corporation, who held his own import contract with Krupp, was squeezed by patent threats and economic pressure until Carbaloy absorbed his die business in 1937. And in 1936, the arrangement went global. Krupp agreed to stop exporting Widia into the United States, and General Electric agreed to stay out of the rest of the world. Two companies, one German and one American, had quietly divided the planet's hard metal market between them. The consequence was exactly what you would expect. At $400 a pound, most American shops simply never adopted carbide. While German industry retooled itself with cheap, abundant Widia through the 1930s, the country that would soon call itself the arsenal of democracy rationed the miracle metal like jewelry. But the money was only half the problem. The contract had a clause that aged into something close to treason. Carbaloy owed Krupp royalties on every pound of carbide produced in America, which meant Carbaloy was contractually obligated to send Essen regular, detailed statements of exactly how much hard metal the United States was making, who was making it, and where. As Germany rearmed under Hitler, those royalty ledgers became something no spy network could have matched: a recurring, audited intelligence report on the tooling up of American industry. From those figures, analysts in Germany could work backward, pound by pound, to estimate how many new plants were cutting metal in the United States, and roughly how fast American rearmament was accelerating. Testimony before the Senate later described how the reports kept flowing even after the invasion of Poland, with Krupp officials in Berlin anxious about the royalties still owed to them from American production, and how, once open war made direct payment awkward, the money was routed through an intermediary in Zurich. The trial record and the reporter who covered it describe correspondence in the file that ended with the words, "Heil Hitler." In April 1940, with Europe burning, General Electric wrote to an American customer that it was not permitted to sell tungsten carbide for China, and that the customer should take the business to Germany. Washington finally moved, and the spark, fittingly, was ammunition. Firth Sterling, one of Carbiloy's two reluctant licensees, had been selling carbide blanks to the Army for turning artillery shells, and in doing so ran afoul of the price levels its license bound it to. The friction surfaced the whole arrangement to federal lawyers, and once they started pulling on the thread, the entire cartel came out of the wall. In 1940, a federal court in Michigan hearing a patent case against a small shop called Willys Carbide Tool Company declared the Schröter patents invalid, knocking the legal foundation out from under the entire structure. That same year, the Justice Department secured its first indictments, and on October 21, 1941, the formal indictment came down. 4 counts under the Sherman Antitrust Act, plus a count under the Wilson Tariff Act, naming General Electric, the Carbiloy Company, International General Electric, GE Contracts Manager Walter Stearns, Carbiloy President Walter Robbins, Zay Jeffries himself, and Friedrich Krupp of Essen, indicted in absentia while its factories forged guns for the Wehrmacht. Then, in April 1942, with American troops already dying in the Pacific, the confrontation went public. The Senate Committee on Patents, under Senator Homer Bone, opened hearings into war cartels, and Carbiloy sat at the center of them. Justice Department attorneys laid out the price fixing, the refused licenses, the royalty pipeline to Essen, and accused the cartel of leaving America with a drastic shortage of the one material that could multiply war production. A witness told the committee that a carbide-edged tool could be reground and reused 1,000 times, against roughly 100 for anything else. The room heard testimony that the cartel's prices had kept that tool out of most American shops for a decade. The head of Firth Sterling himself told investigators what the pricing had done to the market, that a large number of firms had simply never used carbide at all because of what it cost. And at one point, Walter Robbins, the president of Carbiloy, could not contain himself any longer. He rose from his seat in the hearing room and declared, "I refuse to be called un-American." Carbiloy's defense, then and later at trial, was that it had never sold a mere product. It sold a premium tool service, engineering support and application expertise bundled into every gram, and that service, the company argued, was carrying the American war effort on its back. The committee was unmoved. But there was a war on, and the country needed Carbiloy's furnaces running. The criminal trial was postponed until the shooting stopped. Here is the bitter irony of the war years. Once the government broke the cartel's grip and the price floor collapsed, cemented carbide did exactly what its inventors always knew it could. Production exploded. High-speed steel tools cut at 50 to 100 surface feet per minute. Carbiloy-tipped tools ran at 300 to 500. Across Detroit, across the aircraft plants and the gun shops and the shell lines, that difference compounded into something strategic. The same lathe, the same operator, the same shift, turning out 3 or 4 times the parts. Aircraft engines, naval gun barrels, artillery shells, all of it flowed over carbide edges. And behind every one of those edges stood the powder rooms in Detroit, running around the clock, where workers weighed out tungsten carbide and cobalt by the ton, charged the ball mills, pulled the pressed compacts, and ground the sintered tips in a fine gray haze that settled on their hands, their hair, and their lungs. Nobody in 1943 had a name for what that haze could do. Hold that thought. We will come back to those rooms. And then the material went to the front lines itself. American tank crews in Europe were meeting German Panthers and Tigers whose armor shrugged off standard steel shot. The answer was to weaponize the very properties that had made tungsten carbide a cutting tool. Nearly twice the density of steel, nearly the hardness of diamond. Carbiloy's Detroit operations produced tungsten carbide cores for high-velocity armor-piercing ammunition, including the 90mm HVAP round designated M304, a dense carbide dart seated inside a lightweight aluminum body. Fired at enormous velocity, the aluminum carrier crushed away on impact, and the carbide core punched through face-hardened German plate. Engineers at the Watertown Arsenal outside Boston tested the design against armor and reported that straight tungsten carbide cores were, in their words, decidedly more efficient at penetration than standard armor-piercing steel. For a Pershing crew staring down a panther across a Rhineland field in 1945, the difference between a steel round and a carbide-cored round was the difference between a dent and a kill. The metal born in a lightbulb laboratory was now opening German tanks like tin cans, and Zay Jeffries lived both halves of the contradiction at once. While standing under federal indictment for the Krupp cartel, Jeffries was quietly serving the Manhattan Project as a consultant to the metallurgical laboratory in Chicago, working alongside the men building the atomic bomb. In November 1944, he chaired the committee that delivered a report to the project's leadership titled Prospectus on Nucleonics, a word Jeffries coined himself, one of the first serious documents to map out the post-war atomic age. The same man, in the same year, was a defendant in a Nazi cartel case and an architect of America's nuclear future. The reckoning came after the war. On January 26, 1947, the antitrust trial finally opened in New York, and it played to a nearly empty press gallery. Through months of testimony, a young labor reporter named James Lerner was frequently the only journalist in the room, watching as the government unpacked General Electric's own files and the captured Krupp records from Essen, the 13 folders in the leather bag from our opening, carried into court under guard and dovetailing, document for document, with what investigators had found in Schenectady. On October 8, 1948, Judge John Knox delivered his verdict, writing that he was compelled to find each of the defendants guilty of each and all the charges made against them. General Electric, Carbolloy, International GE, Stearns, Robbins, and Jeffries. All of it proven. And then came the sentence. The government had asked for prison time. Knox imposed none. The fines totaled roughly $56,000, $20,000 each for GE and Carbolloy, $10,000 for International GE, small change for the individuals, against a cartel that had spent 2 decades selling a 12-cent gram for $1. One of the largest corporations on Earth had been convicted of conspiring with Hitler's arms maker, and the penalty amounted to a rounding error. 71 years later, in 2019, Jeffries would receive a posthumous presidential pardon, his citation resting on the bomb he helped build rather than the cartel he helped run. Carbolloy itself rolled on, folded deeper into GE as its metallurgical products department, though nobody on a shop floor ever called it that. And its unique skills kept drawing government work. In the last week of June, 1956, under contracts tied to the Atomic Energy Commission, Carbolloy machinists in the Detroit area turned down the outer diameters of uranium slugs, raw fuel for the atomic programs, on carbide tooling, the only edges that could hold tolerance in that dense, punishing metal. The facility had to be decontaminated afterward, and decades later the plant would be listed in the Federal Compensation Program for atomic weapons workers. Through the 50s and 60s, the flagship plant at 11,177 East 8 Mile Road in Warren, Michigan, grew into a complex turning out some 14,000 different carbide and steel products, and the technology kept advancing beneath it, brazed tips giving way to indexable inserts you could rotate to a fresh edge in seconds, and then to coated inserts, thin ceramic skins that multiplied tool life yet again. But there was a cost being paid inside those buildings that no ledger recorded, and it takes this story past the antitrust files and back into the powder rooms we left in 1943. Because everything Carbolloy ever made began the same way. Tungsten carbide dust and cobalt dust, weighed, mixed, milled, pressed, and ground, decade after decade, by men and women who went home every night with the residue of the miracle metal on their clothes. Through the 30s, the 40s, and the 50s, neither company doctors nor the wider medical community understood what that fine metallic dust was doing. The workers were the invisible half of the arsenal of democracy, the ones who never got the ticker tape, and for many of them, the bill arrived 20 and 30 years later, on a staircase they suddenly could not climb. Medicine caught up slowly, one damaged lung at a time. Researchers learned that in susceptible workers, inhaled cobalt does not simply sit in the lung the way inert dust does. It provokes the immune system into attacking the lung's own tissue, and the tungsten carbide particles appear to amplify the assault, carrying the cobalt deeper and making its chemistry more aggressive. The result became known in the clinics as hard metal lung disease, and on the shop floor by a blunter name, cobalt lung. It begins quietly, a dry cough that will not clear, wheezing at night, breathlessness on exertion that a machinist in his 40s writes off as age or cigarettes. On X-rays, the lung slowly fills with scar tissue, stiffening like leather, and in the worst cases, the fibrosis is irreversible and ends in respiratory failure. Some workers developed it after decades in the mills. Others, cruelly, after only a few years at relatively low exposures, because with cobalt, sensitivity matters as much as dose. At Carbolloy's Warren complex, the reckoning began with the workers themselves. In 1985, the United Auto Workers Local, representing the plant, formally petitioned the federal government to come inside, and investigators from NIOSH, the National Institute for Occupational Safety and Health, walked the same floors where the arsenal of democracy had been tooled 4 decades earlier. They hung sampling pumps in the breathing zones of powder handlers, collected urine samples to measure the cobalt passing through workers' bodies, and screened lungs for early scarring. Their report, completed in 1988, confirmed what the union feared: a cobalt exposure hazard in the powder operations of Building 6, with airborne concentrations among workers not wearing respirators measured at many times the recommended limit. NIOSH ordered tighter respiratory protection, engineering controls on the dust, and ongoing medical surveillance for lung disease. In the years since, Michigan's occupational health registries have tied dozens of confirmed cases of hard metal lung disease and cobalt-related asthma to the state's carbide industry. And the International Agency for Research on Cancer now classifies cobalt with tungsten carbide, the exact mixture at the heart of every Carbolloy product, as a probable human carcinogen. For the workers still on the floor, the changes were immediate and unglamorous. Fitted respirators in the powder rooms, enclosed mixing stations, annual chest X-rays and breathing tests, and a urine cup handed over at the plant clinic so the company could count the micrograms of cobalt leaving your body. For the ones already sick, the report changed nothing except the name they could finally put on what was happening to them. There is no cure for hard metal fibrosis, only oxygen, transplant lists, and time. The machinists who armed the Shermans and the Pershings, and the powder room crews who followed them on those floors for 40 years, paid for the century's hardest material, an invisible gram at a time. By the 1980s, the ground had shifted under the whole business. General Electric under Jack Welch was ruthlessly shedding any operation that could not be first or second in its market, and the American cutting tool trade had become a global knife fight against Swedish, German, Japanese, and Israeli carbide makers, who had spent the post-war decades perfecting the very technology the cartel once hoarded. The Carbolloy name still meant something on every shop floor in the Midwest. The margins no longer did. The buyer, when it came in 1987, carried a fitting pedigree. Sacco Tools of Sweden had grown out of the old Fagersta steelworks, which had been making its own cemented carbide under the Secco name, Latin for "I cut," since 1932, almost the same vintage as Carbolloy itself, and had spun off as an independent carbide company in the 1970s. Secco bought General Electric's Carbolloy operation, and for 2 decades the business traded in North America as Secco Carbolloy, Swedish metallurgy fused onto the old Detroit brand, still headquartered in the Warren complex, still shipping inserts and tool holders to the same automakers. Carbolloy had been refused permission to license half a century earlier. Chrysler and Ford, once turned away from the technology at any price, were now simply customers. In 2007, the hyphen finally dropped, the company becoming simply Secco Tools, and in 2008, the North American headquarters left the historic Warren complex on 8 Mile for a modern campus in Troy, Michigan. The Swedish giant Sandvik later absorbed Seco into its group, placing Moissan's accidental compound, Schröter's patent, and Carbaloy's legacy inside one of the largest engineering companies on Earth. The material itself never stopped advancing. Modern inserts wear engineered coating layers a few microns thick that let them cut hardened steel dry at speeds no one at the Leipzig fair could have processed. And in a turn, the cartel bosses of 1935 could never have imagined, the industry now runs buyback programs to recover worn carbide inserts and solid cutters, because tungsten and cobalt are too scarce and too valuable to throw away. Used tools are collected, reclaimed, chemically broken back down, and reborn as new powder, so an insert cutting engine blocks in Michigan today may contain tungsten atoms that have been circulating through the trade since the Truman administration. The same gram of carbide that was once priced like treasure is now recycled like it. Walk into any machine shop today, anywhere on Earth, and open a tooling drawer. The gold and black inserts inside, the solid carbide end mills, the drills that chew through hardened steel without slowing down, every one of them is the direct descendant of the sliver Samuel Hoyt carried home from Berlin in his pocket. The industry that grew from it now measures its output in thousands of tons of carbide a year. Tungsten carbide sits in the studs of winter tires gripping icy roads, in the buttons of mining drills a mile underground, in surgical instruments, in the tiny rolling ball of the pen in your pocket. Machinists in Michigan still occasionally call an insert a piece of carbaloy without knowing they are speaking the brand name of a company that was convicted of conspiring with Krupp. The word outlived the corporation, the cartel, the trial, and everyone who sat in that Manhattan courtroom. The invention was never the hard part. Schröter solved cemented carbide in 2 years with a light bulb budget. What took 20 years, a Senate investigation, a world war, and a federal conviction, was prying that invention out of the hands of the men who owned it. Carbaloy, the company, was judged guilty, fined the price of a house, absorbed, renamed, and finally dissolved into history. Carbaloy, the material, built the century, and it is still building it, one recycled gram at a time. The machinists who said the name every day were never told the story behind it. Now you know it. The archive of stories like this one keeps growing, so subscribe to Trade Archive, and we'll see you in the next one.